All right, everybody. This is our, I think it says day 25, but I think it's day 26. I don't know what day we're on. Who cares? The day number really doesn't matter, does it? This is our starter code. We're going to be looking at an actual effective use of this. The command I tell you don't ever use this is there's a use, it's select. We're going to look at friend functions and we're going to look at our own namespaces, which is not in the starter code, but we're just going to do that on the fly. I bet that's Juan saying why he can't be here. Yeah, we're doing that today. So get that code in your system. I have it here, and let's just read through what's going on. So there's not a lot in the includes. We got an IOStream and CMath. We've got a structure for point with just X and Y. We can see that X equals 0, Y, it's a normal Cartesian coordinates. They have this X equals X and this Y equals Y. This is not the helpful one. This one's just as good. But a good use of this is check out these, set X and set Y. We're taking in integers, assigning it to X, and then we're returning this. This is not the X. This is the point that X is part of. And it may seem like that's not all that useful, but now we've got something where in the code, when we plug it in, it returns the point that it's part of. And it allows you, I'm going to just come and jump to the point real quick in the main. Look at this fucking line here on 82. Object one set dot set X dot 10 dot set Y 20. We can't chain together these operations without that this. But this set right here returns a point. And so now with that point that's returned from set X, from this command, we can then chain set Y. So you can do a point all at once. That's kind of interesting. And there's no, like, if we just looked at how set X and set Y work, there's nothing in that thing without the command this that would give us the point. I can't return X and Y because X and Y weren't passed in. I can only return one thing. And this is like, it's hard to use the word this without referring to that. Our point right here, we're passing something into this point. So it's hard to reference what that point is from within it without using this. So that's an example of this that's actually helpful, that allows you to chain shit together. But this isn't. This is just as good with doing argx and argy, and it's actually a little bit cleaner. What are you doing sitting there? That's not your spot. They fucking stole your spot, Gus. He messaged me at, that's a good question. He messaged me at 3:45 and said he's having car trouble. And I've been trying to see what's wrong and maybe trying to fox all morning. I assume he means fix, but I don't think I'll be able to make it to class today. And so at 4:45, I said, you know, just because you're having car trouble doesn't mean you can't log in on Zoom. I don't think he's here. Let's go look. Nope. Slacker. It's the end of the semester. Why would you're cold? I thought he was your friend. Fucking fire him, right? Another use of this is right here, but I don't know that it's important because if you're it's trying to distance to point. If you're within one point object and you want to find the distance to another point object, I think the better way is just have a function outside that you pass in 2 points. But this doesn't do this. Our structure right here has a method within that just says, take my current object and find the distance to another point. So it does this x. You know, this is the whole square root of x squared, x2 minus x1 squared plus y2 minus y1 squared. That's what this function is the distance formula. But it's doing this x and arg x. I think you could have just done x minus arg x and still been just fine, because x is part of our function. So that's kind of the thing with this. There's uses for it, but most of the time we see shit like this where it's not important. That works just as well. So why are we adding an extra command to say this, other than to make it clear we're not talking about argument x? But I think the arg pointer x kind of gives it away. And if you're really having people with that are not that skilled with it, we could say int y2 equals, you know, and label them something different where it's not confusing what the x and y is. So I don't think that this thing is good for very many things, but there were some examples here that had it. I'll put that back to where it was. I wanted to scroll down and we're going to talk about static variables and stuff like that. In here, we actually have a static. And so we haven't used static before because it's never been needed before. But if you've ever played the game Asteroids, and it's a fucking old game, you're in a little ship, and asteroids are flying around, and you like basically shoot straight out from you, and you spin in a circle, and you can fucking spin really quick. And you're shooting the rocks, the asteroids, and trying to blow them up. The object is to blow up all the asteroids. So, like, keeping a counter of the asteroids is pretty handy. That's what this is modeling. So we have an int count here for the number of asteroids that are going to be in play, but it's part of the class rather than an outside thing because it belongs with the game. So static allows it to be shared by all the asteroids. Every asteroid can or access count, and they're all using the same value.
Can like children classes also include it like that?
Should be able to, yeah. So like this count, every asteroid, if we've got 10 asteroids in play, count would say 10. And for any asteroid that access the count command, it's going to return 10. Even the first one that was created when it was only a 1. The first asteroid was a 1. As each one was created, its counter got to go up too. So that's kind of neat. But you want to initialize it outside. So when you have a static command, because if we have the 0 in there, it's going to reset count to 0 every time a new asteroid is created. We don't want that. So we're going to set the count to 0 before it starts, before the main, and then we can access count with any of the asteroids. That's the use of the static class or static function. Kind of handy to be able to share something across all objects. But there's a lot of times you don't really like, not very things need it. Like maybe if we're talking about cars and you're like, or something like that, they all have 4 wheels. Well, that's not true. Some trucks have, or, you know, they have 6 wheels, 8 wheels.
Maybe like different type of drive.
So there's uses for it, but that's how static works. There's something else in here. If you scroll down, you'll see friend. If you do the friend command in front of a method, then you can have the method outside the class. Notice it's the same. Print asteroid count, and we don't need the get command anymore. So friend allows access without get command. So like a print function is pretty much all you really need it for. There might be other things that you want to use it for. Again, I don't know how useful this is. That's why it's at the end. The last module where it's like, this is like extra shit. Both of these, remember, you're going to have to scope them. But I think this one is the static is cooler than the friend because having something that they can all access, a shared variable where it updates all of them as it changes. And that's what's going on. When you create an asteroid, the count goes up. When you destroy an asteroid, the count goes down. So it's in the constructor and the destructors. That was the fun stuff with this, or being able to return the point. So this, like we could have done this here. This to do with the point here where we returned this. But like if we did it with the asteroid and we need to reference the asteroid for something, we could return this on something in here and it's going to return the asteroid it's talking about. So maybe if there's different colors, different sizes, and when they get down to a certain size, you could have it say something. That's kind of it for the static and this and friends. I haven't really changed a lot on the code. Everyone kind of okay with that? You're not the person who should ask because you like always say yes. All right. Namespaces. So I'm going to shrink this down. I'm going to shrink this down. And let's say I have, what's a fun little function that we could do? How is that a fun little function? All right. So we'll make it a double. Law of cosine.
There's a cosine function.
So what do we need for the law of cosines? This is why. We kind of need, we got the points. Let's use the points. So let's take in point arg A, point arg B, and point arg C. And unfortunately, there's a lot of ways to use law of cosines. So if I'm doing a double here, I'm trying to like return a side. So I'll say side. That's the base form. That's what the formula is set up for. All right. So what do we got? C squared equals A squared plus B squared minus 2AB cosine C. Each of these has a distance formula. So that's kind of handy. The point structure had a distance formula. We need the angle.
We can do like a return angle if you put the point.
Right. So we're gonna need something that returns an angle. So let's write that one down. Angle maker. And maybe I'll put that before law of cosines down here. All right. Gus, walk me through this. What should I do? Let's see if you can do it off the top of your head. He knew the law of cosines the other day off the top of his head, which is impressive.
So if you want an angle, which one? The one in the middle?
Let's say we're finding angle B. No, since law of cosines uses C, let's say we'll find angle C. So maybe we'll have the ACB triangle or angle.
I mean, you have to calculate the slope and then move the span. That's how you do it in math.
Okay.
So you're going to can I use board?
Yeah. See how much he remembers.
Point is just next y, right?
Yeah.
So you have the point A, point B, point C. You want to find this angle.
Yeah.
So you want to find this slope. This slope. Actually,
How's the slope hoping?
um,
Does in a way, but I wouldn't call it the slope.
you want this angle, right?
Yeah.
So what I was thinking is you can like, with the slope you can get this angle and this angle,
Uh-huh.
and then this angle would be like just 90 minus this 2, right?
All right, let's look it up. Nice handy way.
So this angle alpha, this angle beta, alpha is just the inverse tan of the slope, which is y over x, and beta just the inverse tan of this other slope, right?
I think your alpha's correct, I'm not sure that you do.
It's- And then
But that doesn't give you the full angle.
I mean, no, the angle is just 90 minus this 2 minus alpha and beta.
Not the way you got it written.
Yeah, this is beta.
I see extra, like I see an extra bit right there. Unless you're trying to make it orthogonal.
I mean, but it is orthogonal because it's parallel to this line.
I'm looking at your two dashed lines.
Oh, okay.
Let's see if there's a quicker way. That seems like a lot of work. I gotta use tangent and shit like that. That might be pretty good. Find angle with 3 points.
I mean,
Oh, they used law of cosines. That's fucking great.
yeah, that's easier.
So P12 is the length or distance. Yeah. Yeah. What am I saying? So we've got C squared. Let's just write it in terms of what we see on the other ones. C squared minus A squared minus B squared. And this is cosine C equals that divided by -2 times A times B. So we want arc cosine, which is A cosine in C math, right? This feels like cheating. This so feels like cheating. We use the law of cosines to find the angle just so we can make a function for law of cosines. What was I coming over? Oh yeah, C math, arc cosine. A cosine, okay. Right, right? Is only the value to be passed in, okay. All right, so let's see. Our distance formula up here was what? Distance to point.
Well, that's from like. That's really just a distance.
Right.
Squared plus the y.
I'm seeing how I can use this easily. So if I go arg A and I pass in arg B and do distance to point, let me copy that down there. So we're going to go with double A equals distance to point or arg A dot arg B. God damn it. Why'd you have to pick law fucking cosines? God damn it, this is a long one. It needs to be a pointer though, and it's not a pointer. Address. Address. There you go. So this is length from A to B.
Whoa. That's usually like from B to the right.
No, it isn't. This function goes from this x to arg x.
Oh, I see.
So we'll do double B, arg B dot distance.
We're really just reiterate.
Yeah. So this is B to C. And we need A to C here. So this is arg A. And let's see. I'm gonna make a triangle here. We'll call this A, B, C, or arg A. So that makes this side A. God, that's a shitty A. This is side B, and this is side C. And if we're looking for this angle here, wait, hold on. I said I did that. You're right. That's wrong. Where's my end tape? Where's the fucking annotate bar? There it is. It's hiding. I'm just over here randomly assigning them. Okay, so A to B is labeled as A. And B to C is labeled as B. I clearly have these labeled poorly. You know what? Fuck, that's what I'm saying. So we're relabeling them. A to B is going to be C. And B to C is going to be A. And that's got to be B. That's what the triangle I have set up. Okay, and so now they're labeled correctly. And so we can do return a cosine. If we want C squared, maybe I should change the signs here. Maybe we should make that by getting rid of that minus, making this positive. making this positive and making the C squared negative. How's that sound? So we want to return, I'm going to make some space in here. We want yeah, this needs to be in parentheses. Pow, a comma 2. What? You're right. You're right. That's much. I don't know why. I fucking know, but I'm ashamed. That seems like what we need to do. Why would I use law of cosines to find the side when I already had a distance formula? You know what I mean?
I like it.
Angle maker. All right. Let's come up. Let's make some points. Let's do some points that, where's my main? There it is. Let's comment out all the asteroid shit. Fuck asteroids. And I'll just comment out that. And we'll do 0, 0, which I think is the default. Point object 2. Let's do the 3, 4, 5. Because then we know what the answer should be. Well, do we? No. Why don't we do 3, 0 and 0, 3? 45-degree angle.
No, we'll make it three, right?
What?
No.
So let me change my picture over here. Because we want to make sure we're passing the right shit now. So I called that 1. This was 2. And this was 3. So let's say we're finding angle 3. So this is C. And one of these is A and one of these is B. How do I make sure C is 0.1 and 0.2? Let's go look at our code. We want C to be 0.1 and 0.2, which means it needs to be 3 needs to be the last one. I've labeled them well. This will work. If I do object 1 and object 2 here, this will be object 3, and everything should line up happily. I like extra. I hate when, because you have that big old box of C++. I don't like it. It makes it harder to fucking read what's going on. I like the space. Quit looking at me like I'm crazy, Gus Gus. I will comment out law of cosines. And yeah, I already deleted it down below, so I'll just delete it. I guess I could have everything for namespace I could have just done with asteroid, but I didn't want to do that, which is pi over 2. No, pi over 4. What's pi over 4? It's approximately that. 3.75 would be 3, so it should be a little higher than 0.75.
Power four is, it should be a little more than 0.75. Oh, no, yeah, you're right.
I know. 3 divided by 4 is a quarter, 3/4. It's a little higher than 3/4. All right, so our thing works. Let's get rid of that annotation shit. All right, so what was the point of this lecture? We were going to talk about namespaces. So, like, we're really proud of what we made here. We're going to throw this in a namespace. So what I'm going to do is I'm going to make a header file, and I'm going to call it hefe.h. Oh, well, let's go with gusgus.h. Yeah. So go to header file, right click, add new file. Make sure you do header file, whatever you want to name it. And I'm going to also do one for the short resource folder. Make sure you name it. It's just like doing fucking brain farted. Just separation.
All you're doing is just building a file.
Yeah. Yeah, I named it after you.
No, he said he already has the H file. Yeah. Oh, I do.
All right, so I think we need point in there, and I'm gonna move point in there. Fuck it, let's move them all. Let's move everything over there. I feel like some of these should be over in the other one, but fuck it. I'm gonna leave class asteroid in here. This is not good. I should have the asteroid in the header file, but I don't think, I think you know that you'll be fine with that. And we will take, I'll delete that now. I pasted it. And I am going to using namespace Gus. Nope. Let's include Gus. And I'll do copy that over to Gus CPP. And now I'll come down here and I'll steal angle maker and put it over there. That doesn't feel right. That's just regular separation.
So check it out.
I'm gonna load something I did earlier.
Make sure you keep that from, if you get rid of it, that's specific to see.
Oh, there we go. I use, okay. I'm sorry, what was the question? I made a header file and a CPP file in the resource folder. One header file, one resource file, both named the same thing. Other than one's got .h and one's got .cpp.
Yeah.
Your header file needs to be .h. So create another one. Delete that one. Yeah, on the like the drop-down list. So now everything is in Gus. This is a dumb name, but oh well, I already made it. So if I want to use point, which is not defined here, why is this doesn't seem necessary? Yeah. Hold on one second. Oh, that's what I gotta do.
Yeah, you have to define the namespace.
Yeah.
It's like, it's a namespace, but like, what is it? The SQL parts.
Right. So this is like, okay. So we're gonna go over to the header file for namespace and or Gus, and I'm gonna say namespace Gus. We'll just go with Gus. Has what in it? Do we want to put everything in it? I'm just put angle maker in there. So that's all your implementations. I've moved angle maker over there. What did I do before? Yeah, it just says your implementations. Isn't that what I called it?
Just try using the standard. What do you have your CDB file?
So here, I've got angle maker in here.
Yeah, it's working.
Oh, you're right, it is working out. Motherfucker. So this was Gus. This is Gustavo's law of cosines angle maker. And he's really proud of his angle maker. So he's fucking threw it in his namespace with all his other shit. So if you want to use it, you gotta call him Gus. So when we come over to the main, when we come over to main, if I want to use angle maker, I gotta call on Gus. Even though you're the one that said let's do law of cosines. He went up to the board.
Because this is something daily mathematicians generation.
All right. So we have our separation. And we threw, like Gus could have a whole bunch of shit in here. I came up with one function, but we could have, function A. Can we move the whole structure in there? I hesitate to do that. I think that's going to be a pain in the ass, but fuck it. Well, hold on. Let's save all. Let's run. It was throwing a fit again. Do I have a misspelling here? And now it's fine again. Fucking Visual Studios. And it's not fine. Syntax error. Something missing in Gus. I don't see anything missing. Do you? This is calling on points before points was declared. I'm going to put Gus or namespace after the point. That might be the problem.
Putting at the bottom instead. Don't they listen to this?
It's failing.
Maybe the semicolon at the next page.
Put it down here. Say what? Shit changed color when I did that. I'm not even mad if that's it. Print asteroid count already defined. You know what? All right, fuck off, asteroid. I don't need asteroid for what we're doing, so there we go. Asteroid was fucking it up. So we have our point structure in there. We moved everything over. It's working. We can make this Gus's point structure. So we've got struct point. So now when we use it, and this has everything in it, so we don't actually need to put this over here. Everything's in the header file, but now it's under Gus. So when we're over here, we need to scope this to Gus. So Gus has created his own stuff. And if I've got a different point structure, if I've got it set up differently with different commands in it, different stuff like that, but they're both called point, this allows us to have two different points. So with that in mind, I could, let's do this. Let's copy it all. And I'm going to create a new header to indicate this, a new header called Hefe. And a new CPP resource file called Hefe. Thank you. I'm changing shit, yeah. Maybe I'll just change my print command. My print command looks like this. So I've got my own print command. Other than that, our points are set up the same way. I mean, I could go through and change it, but I don't need to do it for this. Let's see. And Hefe CPP includes Hefe. And so I'll save all. I'll come over to the main. I'll include Hefe. And then I'm going to let's copy that one and change this to Hefe point. And now I'll do object 3A and object 3B. And we'll do object 3A dot print.
Once you set up the point, part of you don't have to do it again, right?
Say that again.
So you define object to be part of
Object 3A was a point in Gus's world.
Okay.
Object 3B is a point in Hefe's world. Once it's defined, it knows where to look.
Yeah.
I don't need to say it again. Did nobody ask? Maybe I'll include another endl here. And then we'll do object 3B print. So they're both points. We're both calling on print commands. But they're now presented differently. So we can have everything, the class names are the same, everything's the same, which might be handy if we're doing stuff, working on the same project. But we can access different ones of them by throwing them in a namespace. So we just threw our shit in the namespace. So now this is my point, and the other one is Gus's point. And his structure is identical to mine other than this. And then we like everything else we did. I wonder if I can use, can I mix points? Can I do object 1, object 2, and object 3B? No, it won't allow me to mix points. So I can't pass in object 3B into object. So it makes it so you can't like fuck with each other's shit.
Which is great if you want to keep it.
Right. So that's like namespaces. And I included everything like I probably would normally leave the IO stream in the main. But I do have a C out here, so I guess I kind of need it in there. And now we got 2 different points. That's beautiful.
So there's no problem if you include iOS on both.
No, because Pragma once makes it so the library only gets loaded once. That's
That's
it. In most circumstances, it's not going to be a big issue if you didn't have it. Because how much is it going to hurt your computer to load one extra library, or load the library twice? But like, just better be safe. Pragma once prevents your memory being taken up by loading the same memory multiple times, or same library.
For smaller projects, it's not that big of a deal, but when you're working on something like a game, for example.
Right. Like, let's say the library is the entire creature database, and you're working. Let's not go with Dark Souls. Let's go with Power World. If you've seen Power, like it's got like all the Pokemon fucking characters, so there's a shitload of creatures, each with their own attack moves and stuff like that. You don't want that being loaded up in your memory a bunch of times. That's it with namespaces. You kind of see like the specialty of it there. We can have the same objects, different namespaces with different commands. That's all I got. So Monday, Wednesday, we've covered everything. We've learned everything I'm going to teach you. So Wednesday night, is it Wednesday night? Let's take a look. I don't want to say the wrong shit right here. It's when the finals due, right? Have it in by midnight. If it's not in by 11:59, you're fucked. Because shit's getting assigned at like 12 for peer review. If you're not in, don't email me at 12:05 and say, please help me, because it's too late. You've had 2 weeks. At that point, you'll have had 2 weeks. But since I don't have new content on Monday and Wednesday, I will be here. And if you're working on your project this weekend and you come in any stumbles like that, come on in, ask me questions, bring your laptop, and we'll look at it together. I will not code it for you, but I will help you do error tracking and shit like that. Or brainstorming. If you're like Monday, if you come in on Wednesday, I hope you've got your project started. If you're just starting your project Wednesday night, you got very little time. You're racing to get it done, and now I'm worried you're going to be right. That Colin was asking me a real question, and then I saw him smile. I'm like, oh, he's fucking joking. Well, it could be like maybe you deleted namespace STD or something like that. Right?
What is this?
Ask your girlfriend. Boom! Mic drop. I could have said no. That's too far to say. Ask your mom. You probably don't have a girlfriend. Do you have a girlfriend, Gus? Don't have time for her. I'm too old to say that. But not old. No. You're too old to say it, but not old enough for it to be true. I love math too, but I love my wife more.
I don't know why. I don't know. That's the only thing in my heart.
I love girls more. That sounds creepy. You know what I mean? I think you know what I mean. I'm not like looking at all around. I love my wife. I'm not like gawking at everybody. But like before, when I was in your point where I didn't have a girlfriend, I wanted a girlfriend. I was not saying math is my mistress. That's no. I'm fucking with you. You do you, Gus.
Every night you go sleepy, you know.
Cry yourself to sleep.
A couple intervals.
I will have Zoom up on those days, Alex. Yes.
Some visit from for them to I'm out and do.
So this is a funny thing. Cause in fact, I'll show it to you.
Including if you want to fill in spices. Some of this. No, I don't like this. I like this not.
So friends shared with me this math thing this morning. I don't know if it sounds important. I hope you know where this is going, Gus. So they thought this was neat. It's Mr. Bean, which is great. They thought this was neat, but like hopefully y'all know if you've been taking enough math, the property of 11. This is going to work with like this is where it goes to 33, and I'm like, so they sent my friend sent me to this my D&D group, and like some fun math, and I'm like, okay, so I go off into this giant thing, like it's anything with 11. It's kind of like why it works. It looks like magic. I'm gonna pop the magic for you. It's very much the distributed property. If you do multiplication the old way, you're literally doing 10 and 1, and each one generates the same number. So when you're overlapping them, they add. I'm like, it works with any 2-digit number. And I said, and then I was showing, like, I actually, fuck it. Let me go to it, go back. So I show the distributive like there. I'm doing the 1157, and then I come over and do some, I thought I did different numbers. There we go, 53 times 42. Splitting the 50 in 3, splitting the 40 in 2, multiplying, adding. That's how I do double digit multiplication in my head. I could probably do triple digit, but it's the more numbers I'm tracking, the longer it takes. But like I'll do this in math, like the math classes, and I'm faster than a calculator because by the time you pulled it out, I've already done this. And so I was explaining the process to them. They're like, this is so like mind blowing. I'm like, and this is what you get for bringing math out at fucking 8 a.m. But where I was going with this, and I was telling them, I couldn't sleep one night, so I was practicing squaring numbers above like 13 because I knew up to 13 squared. And like I was trying to, what's 14 squared? How would I do that? And I'm trying to do it in my head. I'm trying to fall asleep. And by the time I was up to like 50, I was enjoying myself, like not sleepy anymore. But I had developed a good math skill. Like that's not how I'd done. I would have written it out or something like that. I hadn't taken the time to like actually work on doing this distributive thing. And that's just so much quicker. 5 squares is neat because it's got 5 in it.
Mine's are with all that. It's 15.
All right. I don't know. 25 is even better because this got 25 in it. Oh, 25 squared is 625. So 25 shows up again. Probably 7. Yeah. 7's a great number. I like the number 7. 13 is a lucky number for me. It's my birthday, so like, and oftentimes it falls on Friday more often than you think it would. And they're like great birthday. They've tapered off over the years, but like for a long while, Friday the 13th, when it was my birthday, they were fucking great birthdays. Everybody else is all superstitious and shit. I'm clearly not talking about C++. So if you want to go, you can. I'm just chatting, hanging out with you guys now.
I wasn't sure if you were making a joke. That it's actually 10, 15.
That's why I didn't say 13. Oddly enough, I almost said 13 squared. One's a good number to square.
What's the base?
One, self-referential square. That's awesome.
Two is already good. Two is the only prime. The only even prime.
Oh yeah. 7's the only prime that's divisible by 7. I mean, that's effectively what you just said for 2.
Half of the numbers are even. Like,
I know, but the very fact that the nature of prime, as soon as the first one's even,
I'm just saying, like, two is the only.
2.
Yeah, because for example, 3 and 7 were at odd. At prime.
I feel 1 got gypped. 1 should have been prime. Why is 1 not prime? No, well, the description of prime number is the only two things that make a product of it is itself and 1.
Yeah,
so why can't 1 be a prime number? Because 1 times 1 is 1. Why can't it be prime? Because it's not prime.
No, because the way you define the prime numbers, it has to be divisible by 2 numbers only, which is 1 and itself. Yeah, including 1. Yeah,
But 1 is a number,
is
so
one
it's divisible by 1 and it's divisible by 1.
One number, not 2.
It's not just prime is not described as divisible by 2 numbers.
Yeah.
It's 2 numbers that multiply to make it. There's nothing in it that says it can't be itself.
There is, I'm pretty sure.
And if there is, why? Who gives a fuck? Let prime be prime. Let 1 be prime. Right? What's chat going? Finals due Wednesday. Yes, Max, if you're still here. Yeah.
Ah,
11:59.
I just mixed up today, Wednesday, and next Wednesday, and it was kind of freaking me out. I just needed to be crystal clear.
All right. So, and I'll release something on the peer review because I'll let you know everybody's going to submit like in like a docx or a PDF. And when you copy and paste, if people have long comments, when you paste it in, it fucks it up. It'll go down to the next line. So you're going to have to go in and edit and backspace. But I can't do it any other way because not everybody uses CPP files. So that's the one drawback to peer review. I found that out checking one of the CSCI 1 students that already submitted their code. And I had to do a bunch of editing around, but I don't know, it took 60 seconds. Like on Visual Studios, I don't think he's going to care. So I'll use his real quick and show you. This is my know-it-all student in CSCI 1. I don't mean that in a bad way. He just like answers a lot of questions. He's very passionate about computers.
So 1 is neither prime.
Right. It's the loneliest number. 1 got jacked.
No, it's not. I sent you the
Playground.
1 word prime. So the fundamental theorem of arithmetic says that every number can be written as a product of primes in exactly 1 way, right?
Uh-huh.
So
How is 1 not apply to that sentence?
because
It's not doing it now. What the fuck?
6. So you want to right? Or text on it.
It's got to be PDF or doc or text, TXT, something that everyone can read a doc file or docx file because of having Word through COS. TXT every computer does. TXT file does every computer, and PDF is pretty much on Apple's end. Yeah, run into your computer, make sure it works, and then copy and paste the whole thing into a PDF for it. Why is this working all of a sudden? I must have changed this shit here. It might have. So his shit was like this. Wait, let me find one that's too long.
So this makes it like. No, this makes it like, this breaks like.
So the reason why it can't be prime is because if there was, it would break.
Is- Oh, it's already,
I kind of.
oh, sorry. Let's hear Gus's.
So the fundamental theorem of arithmetic says that every number, any number, can be written as the product of prime numbers, right? And so, for example, 12 is 2 times 2 times 1, right? Which is
Okay.
2 squared times 3, right?
So every number can be written as a product of prime numbers.
So this is the only combination that exists of 12, right? There's no other combination.
With primes, yes.
But if you have like, if you include 1 as a prime number, this will be 1 times 2 squared times 3. But it's the same thing as doing 1 squared times 2 squared times 3. So this is not unique. You know? Because then you can do like 1 to the 600.
Okay. I can buy that.
So this is not unique, right? And you have to state that this is unique, right? This is the only way to write 12.
It seems fucking.
No, I think
It's a technicality.
It is. Yeah, but that's it's all problem. It's like it's just the same thing. Usually, I don't know how that. So yeah, I get it.
But it is not really a problem because anything times 1 is just a cell. So it's not a fucking, it should be
Well, it
a
has to be unique.
Yeah, it has to be
But-
unique.
But yeah, so yeah,
This is not unique.
you could do. so
I
many
understand,
of
I
them.
understand that. But we have exceptions for some things like factorials. Every factorial works except 0. 0 factorial is not 0, it's 1. We make exceptions for math shit for
No,
things.
no, that's just the definition. That's just because the factorial comes from.
Okay, define prime where it's
Okay, okay. So the
a
factorial
product of prime numbers except for the prime number 1. And then prime 1 could be prime. It's all about a matter of how we define it. Exactly what you just said.
Okay, okay. So. No, because that will make the.
I should stop
the
recording because this
theorem
is not.
That will make like, that will break everything.